Welcome to a new test and teardown video. This time it's an MTA 86 Memory Threshold Audiometer by a Danish company called Madsen Electronics. I don't know yet how old this is, but I have already figured out exactly what it is. So look, we got level and we got different frequencies. So the idea is that you use this to test people's hearing. The threshold for the lowest detectable sound. So you can change the level and the frequencies, and then you can say left and right. So this is the manual control, and then you can stimulate some hearing, some headphones, right? So the person got some headphones on, and then you manipulate this in manual mode, or you can run some auto functions, and then the test person pushes the patient. It's actually called a patient. So there's a patient signal that the patient pushes every time he hears this tone at this and this level, and then the test is repeated with a lower and lower level, right? So I think this is why this is called memory. Is it remembers the lowest signal per frequency in left and right, and then when you're done, you can print out a report or some signals or whatever. You can, I don't know yet how that is going to look. And let's have a look here. See, headphones. And the fun thing is that we got separate jacks for left and right, and then that is the patient signal. So, and then there's a serial port. Let me show you. So there's some text here. It says something about 8 bits odd parity to, I don't know, baud rate 2400, right? So that is it's definitely a serial interface. And what else can we get out of this? See? Madsen Electronics AS and a serial number and made in Denmark. That's all I know. How old is this and whatnot, I don't know yet. Ooh, there's a little secret. But how about we just power it up and see what happens? So now I'm ready to power it up. I found some headphones. Look at that. What is this grounding wire with an external connector like that? This can't be right. So let's try and do a little power up test. I actually don't know if this is the main power on off switch. It says nothing. So let me crank on mains voltage and let's... Oh my god. Why are you doing that? But it's not... Stop that. Okay, so there's... Why are you doing this? That is a weird... And there was no... See? Oh! Power LED is on. But nothing else. There's not a lot of intelligent written on this paper. Well, let's open and see what's inside. Look at that. So this is the connector for the printer. But here it looks like there's a match, right? Okay. So how was that? It was like that, right? There is some stuff sticking out there. This is maybe... this is to avoid you can stick in this wrong. So somebody put in 2 pins inside the holes. That's actually smart. And ME is Madsen Electronics, and then there's a part number for the different boards. And that will be the serial interface and probably all the different frequencies or levels or some stuff like that. A little bit of power supply. So here is the printer. I'll disconnect the... I hope... No, it is not. Here is the printer interface. Oh, there's a lot more to it. So that's quite a big board. We got a little bit of modifications here. So that will be power supply to the entire board, right? And this is the printer that's just running and running. Maybe if I disconnect that connector to the printer, then I will be able to see if there's any voltages stuff going on here. What is that? So this is a 6802 CPU, and it's from 1983. The software is 85. Yeah, 83 on the other parts, 84. So yes, this unit must be from 85 due to the software versions, right? See, as you can see now, I got a lot of LEDs alive by turning the power on and off. So I can prove that I can set, or I can confuse some of the output register that's driving all the LEDs and stuff. But see, beep, and then that is it. There is. Yeah, I disconnected the printer so I think there's no life in the CPU. So you gotta see this. The CPU is actually alive. I've been measuring a little bit around here on the different data lines and chip enable signals and all that kind of stuff. And it is quite evident that the system is up and running. Look at the different level problems. It's very, very clear that they got signal integrity issues. Oh, look at that, it's so bad. That's the different data lines. Depending on where it's coming from, it looks like that. And if I go and look at the address lines again, look at that. Some funny stuff, huh? See, this is more like it. This is how it should be. But this is not so nice. But of course it is within limits and all that kind of stuff. But, well, see, much higher address line right next to it. And this is kind of coupling to that one, right? That is funny. Can of course also be some leakage problems, but I bet it has something to do with the layout technique. There's actually a known problem with EPROMs and aging, and they don't really last forever. So it could be that 1985, I think they're just so old that half of the bits they are gone here and there, and that means the program can't really run correctly, and this is why nothing happens, because I don't really find anything wrong that is obviously wrong, and I don't have the schematics or anything really, so there's not a lot more I can do just to confirm that, yeah, all the scan signals there, here, the buttons and all that kind of stuff, it goes all the way in, but nothing really happens. I got all the correct voltages. I got plus minus 12 volts, and I got plus minus this and that. I got everything. Let's try and look a little bit on the CPU card. See, it is a 2-layer board with ultra thin tracks. So everything here is super inductive. And the layout technique here is, if I'm not mistaken, everything is horizontal on this layer and everything is vertical on the other layer. Very, very smart. I actually saw some funny layout stuff I wanted to show you. Oops. Look at that. Isn't that funny? How the track goes into the first via. Well. I will try and clean the context here and see if I can get it any better. So here is the top side of the keyboard and indicator board. There's actually quite a lot of ICs and stuff here, and of course it's because it's driving a lot of LEDs and reading all those buttons. And I think that is actually memory we got right there. Probably a chip select programmable part as well, and I think we got those for calibration, so probably for frequency and level calibration. But still I'm not able to find where this is not working. Oh, by the way, the standoffs for all the LEDs, can you see? Where have you seen those before? That is so funny. I feel I'm about to give up, but of course I go through this board with a thermal camera just to see what I can come up with. And the hottest part on this board is this programmable chip select PAL peel something for that RAM, and that is what I expect, 55 Celsius. That is not a problem at all. Let's show you the CPU. And again, we got this programmable 60, and that is the CPU. EPROMs run quite cold. See, and there's nothing. There's nothing really. It's actually a little bit funny. This one goes quite warm, and those two are ice cold. Isn't that funny? Huh. So this is the one that is driving. They're actually also a little bit different, right? LS244, right? And this is a 245, so they are definitely different. Yeah. Oh yeah, I found some stuff here in the power supply, but I got all the right power supplies and they're nice and clean and all that. I just wanted to show you the design. So it's always good to look at a power supply using a thermal camera. So of course we got a, what is that, filter resistor from the two positive rectifier diodes to the capacitors, and that is a good idea to minimize ripple and magnetic radiation from high voltage or from high current pulses through those wires. So of course if you have a resistor, your peaks will be lower, so that is better for radiation. Good idea. But of course this resistor runs at 120 Celsius. And because of the way that this is mounted very close to the diodes, those two diodes run, of course, warmer. And yeah, we got a resistor down there that is also a little bit warm. Regulators on the heatsink, quite all right. So yeah, I think I'm gonna throw this back to the shed because that was no fun, and I can't really go. I actually can't really continue because everything is alive. It just don't work, and I don't have schematics. I don't have the software. Anybody would just go and replace the EPROMs or some of the programables. But yeah, it scans everything. It's just not responding. Damn it. So, but it could have been so much fun to play with this. I really wanted to play and see, you know, who can hear the best. That could have been so much fun. But anyway, thank you for watching so far. See you tomorrow. Bye bye.